Welcome to the final event of the CAELESTIS project.
The idea of this conference is to get everyone involved in the aviation industry in one single space. So everyone is here, universities, research centers, stakeholders, manufacturers. And I think that it is very important to have these kind of spaces because we can help others in order to reach their goals or learn from the others in order to build the things in a different way. CAELESTIS is about generating a simulation ecosystem in order to improve the design of new aircraft components. In this case, we gather data from design to manufacture in order to connect everything into a simulation ecosystem boosted by the high-performance computed environment in order to have everything in real time. We are improving the design of new components by applying simulation models and doing it in fast and reliable ways. In this case, we can further integrate new tools into the design and to manufacturing process in order to be sure that the new components are being manufactured right and the proper way.
So my work applies to any aerospace parts that will be produced with composite materials. One way of manufacturing composites is to use automatic fiber placement, AFP, where we would lay up dry fibers and then we would infuse these dry fibers in a mold with resin transfer molding. And during this process, the dry fiber will get impregnated. When doing so, we might entrap air, for instance, and create porosities. And porosities are defects that are detrimental to the mechanical performances of the material. And so ideally, what we would like to do is to be able to, in real time, monitor AFP process to determine where we have defects and then be able to predict if this will be an issue for the resulting part. So to be able to do this, we really need real-time simulations.
We've developed all the workflows from CAELESTIS project that are able to train machine learning models, perform Monte Carlo simulations, and generate a lot of synthetic data. And basically we use the ALIA in-house code, that is a finite element code that is able to run a lot of simulations of structural mechanics problems using a lot of CPUs. And this in a close collaboration with the University of Girona. We generated more than 50,000 of high-fidelity simulations using that.
So testing is quite time-consuming and expensive. So with a proper test methodology and a model, you can really reproduce what you do in the lab. So in CAELESTIS, we were mainly working on these two cases. So using or taking the virtual testing to another level. So how the uncertainty from different properties affect your final strength. You cannot go to the lab and test 100 specimens in 1 week, whereas a virtual testing can offer you this part.
I think definitely one big positive aspect of European projects is that they involve people from many institutions, companies across Europe. And in this project, for instance, we had some of the best researchers in composites working together.
Right now, the scenario has changed a lot. Back then, you had 10 to 15 years of development time for an aircraft. Right now, it's not going at that pace. Things have to happen fast, especially with the global emissions and the targets by the European Union. By 2035, you need to have a prototype, and it's quite a less time for you to do the whole product development cycle. So it is at this point the virtual testing really comes into play, where it can really help you to reduce the time and the cost.
We have to enable the industry to be able to implement those technologies in the quickest way possible. I think for me, one key aspect is to have the cooperation and the strong cooperation with the regulatory bodies, because that is the way with which we can ensure that the new technologies are implementable into our products. Especially when we talk about aviation, safety is not compromisable. Therefore, the regulation and the regulatory compliance is of essence. How to achieve it with new technologies is where the devil is and where the efficiencies can be brought, so that you can detect whether a technology has potential to be implemented and to be beneficial for your product at an early stage. And on the contrary, you can detect whether what you're developing has no chance to be certifiable, therefore you should stop investing.
We have to think about what is coming after CAELESTIS, what we are going to do with all the results that we have. Can we apply it into more projects? Can we build it into the industry? That's why we need more pushing regarding the European Commission.